Now to solve question number 3, you can see it is in compound fraction. Yes. Now if you watch my videos on introduction to partial fraction, you will see different ways you can resolve a given compound fraction into its partial fractions. Now if you watch that video by clicking Chidon's Daniel introduction to partial fractions, you will learn a lot. Now let's apply the knowledge here. To solve question number 1, I will say that the partial fractions are a all over, because this is raised to power of 2 and this is a linear factor. Because this is a linear factor and it's raised to power of 2, I will say all over x plus 1 raised to power of 1 plus b all over x plus 1 raised to power of 2. I have satisfied this. Then plus c all over s plus 2. No raised to power because you just raised to power 1. Now, when you have something like this, there are 3 methods of resolving a partial fraction. I need to resolve this. When I resolve it, I get value of a, b, and c. Then I will now integrate. There are methods of resolving a partial fraction. 1 is by cover-up method, 2 by comparing their coefficients, and 3 by substitution method. So we use cover-up method. We also use comparing their coefficients. All we will try to see is that we get A, B, and C. Let's see. Look for LCM. LCM of everything. These are the same. So you say x plus 1. That is their own LCM. Raised to power of 2. This I've covered this. Then bracket x plus 2. This is inside this. That is why I say this one has covered this. Now this divide this, it will remain one of this. One of this divide this, it will remain one of this and this one. This times a. I will have a bracket 1 of this that remain. Then bracket x plus 2 plus this divide this, it will remain this, b bracket x plus 2. Then this one divide this, it will remain c bracket what, x plus 1 all square. I will say it is equals to x square plus x plus 1 all over x plus 1 all square bracket x plus 2. This expression is the same thing as this. That is what, from here is where we got this. Now you say, since we have a linear factor there, make that linear factor to be equal to 0. If I make x plus 2 equal to 0, I will have x equal to minus 2. I will take it and put it to these numerators. If I carry minus 2, bring it here. Minus 2 plus 2 will give me 0. 0 times this, 0. 0 times this, 0. Minus 2. Minus 2 plus this will give me 0. 0 times this, 0. Minus 2 plus 1, minus 1. Minus 1 times, minus 1 raised to the power of 2 will give me 1. 1 times c will give me c. Equals to minus 2 raised to the power of 2 is what? 4. Then minus 2, then plus 1. That will be giving you that c is equals to 3 from using cover-up method or direct substitution, because we just use direct substitution by carrying this, equate it to 0 because it's a linear factor. Then when you equate it to 0, say since I've equated it to 0, that my x will be equal to minus 2, and I put it here. So that is by substitution method. I've gotten my c to be 3. I will write it up top of this part. I will now say to get my A, B, and C. To get my A, B, and C. Now, to get my A, make x plus 1 to be equal to 0. X plus 1 equal to 0. My x will be equal to minus 1. minus 1, 0. Everything will be what? 0. Minus 1 plus 2, what will it give me? Minus 1 plus 2 is 1. 1 times b, b. Minus 1 plus 1, 0. Everything here will be 0. Then equals to minus 1 squared is 1 plus, minus 1 squared is 1. Then x is minus 1, then plus 1. 1 minus 1 will have it to be 0 plus 1. Therefore, b is equal to 1. We have gotten another one that b is equal to 1. And we got it also by direct substitution. We now try to get our a. To get our a, I will multiply everything and use comparing the coefficient method to get my a. I will clean. Now multiplying everything, I will have it that x times x is x squared. Then x times 2 will give me 2x. 1 times x will give me x. 1 times 2 will give me 2. 2x plus x, 3x. 3x plus 2. So I will be having 3x plus 2. A bracket x squared plus 3x plus 2 plus this one will give me bx plus 2b plus this one, to expand it, c bracket x squared 2 times x, 2x times 1, 2x. Then 1 square is 1. I've expanded it. These answers we got here, please, we need to sort them out. This means a x square expanding plus 3ax plus 2a plus bx plus 2b plus cx squared plus 2cx plus what? C. We have expanded it. Now our concern is to collect those that have power of x squared. We now say we have a x squared plus cx squared. They are the two that have power of x squared. We say this equates to what? X squared. Now at this point we will be getting, at this point we will now say that a plus c factorizing is equal to x squared. This is x squared, this is x squared. The coefficients will now be equal. Therefore, a plus c equal to 1. The question is, what is your what? C. Your c is 3. Your c is 3. You now say a equal to 1 minus 3 equal to minus 2. So a is equal to minus 2. We have gotten our a, our b, our c. Since we have gotten our a, our b, and our c, we come and put it in our general formula and say a all over x plus 1. What is our a? We say minus 2 all over x plus 1 plus b. What is our b? 1 all over x plus 1 all what? Squared. Plus c 3 all over x plus 2. So we have resolved this and we say is equal to what? X squared plus x plus 1 all over x plus 2 all squared bracket x plus 2 x plus 1 all squared bracket x plus 2 dx. Now, if we say we are integrating this, it means I am to integrate this, integrate this, integrate this. That's the meaning of integrating this. I've resolved them to partial fraction. It is now time for me to integrate. Now, this, to integrate this, I will say bring out minus 2. That will remain integration of 1 over s plus 1. And integration of 1 over s plus 1 means ln or log s plus 1. Integration of 1 over s plus 1 means log s plus 1. So I will clean this and I will write log x plus 1. Then for this one, I will say to integrate this. If I differentiate what is inside, what will it give me? 1. Because differentiation of s is 1, differentiation of 1 is 0. Then that one I got, invert it still give me 1. That means, this means 1 integral 1 over what? U squared. And that means I'm integrating u raised power minus 2 from law of indices. And that means add 1 to the power, it will give me u raised power minus 1 all over minus what? 1. Then that means my answer will be minus 1 over what? U. So if I integrate 1 over x plus 1 squared, I'll be having minus 1 over u. And my u is s plus 1. My u is s plus 1. So it will be minus 1 over s plus 1. I will clean this to write it minus 1 over s plus 1. I will say minus 1 over x plus 1. Then to integrate this next one, I will bring out this 3 out. It will remain 1 over s plus 2. Now to integrate 1 over s plus 2, it's the same thing as log s plus 2. So this one will give me 3 log x plus 2. I will carry it and come and replace. I will say that this one is 3 log x plus 2. So answer is minus 2 log x plus 1 minus 1 over x plus 1 plus 3 log x plus 2. Then if you leave your answer this way, I will tell you you are wrong. Why? Because you didn't put plus c. Plus c means it doesn't have upper and lower limit.